Welcome everyone. Math 103, we're working on section 3.5 today. Last chapter, we learned how to translate phrases into mathematical expressions. Now, we're going to translate whole equations. So what differentiates expressions from equations is the equal sign. Expressions don't have an equal sign. Equations do. So we need some keywords to indicate the equal sign. And you can see at the top of the packet, you got some keywords listed there. Is, equals, is equal to, amounts to, represents. These all mean the equal sign. The one we're going to use the most is. So look for that keyword is. And that's where we're going to place the equal sign. For example, we're going to translate 12 more than the number is 18. And then we're going to solve the equation we write. So as we saw before, more than indicates addition. A number, this is just a variable. Any variable will do. So we're going to start with a variable. I'm going to call it n. 12 more than that, n plus 12, is the equal sign. So put an equal sign there, and 18. So this translates into n plus 12 equals 18. And we'll go ahead and solve this by subtracting 12 from each side, and the number is 6. All right, use this technique on your turn. We're going to translate a number reduced by 11 by 7 is 11, and then solve it. Reduced by, this is subtraction. So we'll start with our number, reduced by 7, so n minus 7 is the equal sign, 11. I'll add 7 to each side, and n is 18. Number 2, translate the sum of 3 and the quotient of a number and 8 is 27, and then solve it. So just like with expressions, we can start off by translating the simple expression first. The quotient of a number and 8. Quotient is division, so that translates into n divided by 8. So we can rewrite this. And all I've done here is replace the underlying expression with n over 8. Now we can translate the sum of 3 and n over 8 is 27. Sum is addition, so we're going to add together 3 and n over 8. Is the equal sign, 27. And now we can solve this. So I'm going to get rid of this fraction and multiply the entire equation by 8. 8 times 3, that is 24, plus, with this term, the 8's cancel, leaving just an n, equals 27 times 8, 216. Now we can subtract 24 from each side. And we get 192 for n. Next up, we're going to translate the product of 4 and the sum of twice a number and 5 is 60, and then solve it. Let's start with the simple expression. The sum of, oops, that's not the simplest expression. We'll start with twice a number. Number is just any variable. Twice is 2 times, so 2n. Replacing the underlined phrase, we got the product of 4 and the sum of 2n and 5 is 60. So next simple expression here is the sum of, oh, it should be the sum of 2n and 5. So sum is addition, so this is translated into 2n plus 5. Now we need to translate the product of 4 and this thing is 60. Product is multiplication, so we're going to go 4 times this thing. Got to put it in parentheses because we're multiplying by this entire expression. Is this the equal sign? 60. Now we can solve this. 2 different ways we can solve this. This entire side is multiplied by 4, so we could divide by 4 on both sides. And that gives us 2n plus 5 equals 15. The other way to solve this is to go ahead and distribute, and then we've got a regular linear equation to solve. That works too, but I think this way is faster. Now we can subtract 5 from each side, get 2n equals 10, divided by 2, and n equals 5. Next up, we're going to start solving some problems involving consecutive numbers. We're also going to look at even integers and odd integers. So even integers, those are all the ones divisible by 2. So they can be negative as well. So you got -4, -2, 0, 2, 4, 6, 8, and so on. Odd integers, -1, +1, 3, 5, 7, and on and on. Consecutive integers are those that are in order. So you may have 2, 3, 4. Those are 3 consecutive integers. Or -10, -9, -8. Those are also consecutive integers. Consecutive even integers, those are even integers that are in order. So 2, 4, 6. Those are consecutive even integers. Or -16, -14, -12. Those would be consecutive even integers as well. And then you've got consecutive odd integers. So 1, 3, 5, 21, 23, 25, stuff like that. Now we're going to create expressions for consecutive numbers. So you can see the box there. What I'd like everybody to do is write an expression telling how you would find the next consecutive number from 7. Now it's clear the next consecutive number is 8, but don't write down 8. Write down 7 along with something else. How do you get an 8 from 7? And then the next consecutive even number, we're starting with 12, so your expression should have a 12 in it. What do you need to do to 12 to get to the next consecutive number? And then do the same thing for the next consecutive odd number from 9. Write an expression with 9 in it, and then how do you get to the next consecutive odd number after 9? Once you have those done, instead of starting with a specific number, like 7, 12, and 9, start with any number. Represent any number by a variable. So for the first one, next consecutive number from 7, we'll start with 7. To get the next consecutive number, we need to add 1 to it. And if we start with any number, instead of 7, I'm going to write down a variable. So from the number n, how do we get to the next consecutive number? Well, we add 1 to that. So here's an expression for the next consecutive number from n. Now the next consecutive even number. If we're starting with 12, how do we get to the next consecutive even number? Well, let's think of an example. 2, how do you get to the next one? That's 4, so we add 2 to it. If we start with 12, we need to add 2 to get to 14, so 12 plus 2. Now using a variable, starting with any even number n, we have to add 2 to that to get to the next consecutive even number. And for odd numbers, we're starting with 9. To get the next consecutive odd number, that would be 11. So add 2 to it. And if we start with a variable, assuming this is an odd number, we would add 2 to that to get to the next consecutive odd number. So we're going to be using expressions like this to solve problems. Example, the sum of 2 consecutive numbers is 19. Find the 2 numbers. So we have 2 different numbers in this problem. The first one, well, that one's easy. We just define some variable to represent the first number. The problem says it's 2 consecutive numbers, so we need an expression then for the second number. We don't want to have to define a new variable then, because then we won't be able to solve the equation because we have 2 variables. We can only have 1 variable in the equation. So that's where we refer back to this. If the number is n, the next consecutive number is n plus 1. So n plus 1 is the second number. Now we know that the sum of these is 19. So sum is addition, so we're going to add these two things together. N plus 1 is the equal sign 19. Now we can solve this equation. We've got 2 n's over here, so we'll combine those into 2n plus 1 equals 19, so combine like terms. I'll subtract 1 from each side to get 2n equals 18. Divided by 2, and n equals 9. So there's our first number, 9. So that means the 2 numbers are 9 and n plus 1, or 9 plus 1, which is 10. 2 numbers are 9 and 10. And just as a check, we're supposed to be able to add them together to equal 19. 9 plus 10 is 19, so that works. Your turn. The sum of consecutive even integers is 34. Find the two integers. So if the first number is n, we're talking about consecutive even integers, so we need to add 2 to get to the next one. So the second number would be n plus 2. The sum of these is 34. The sum of these two expressions, n plus 2 equals 34. Now we can solve. Combine like terms, you get 2n plus 2 equals 34. Subtract 2 from each side. You get 2n equals 32. Divide by 2 and we get n equals 16. So the two numbers are and then we add 2 to 16 to get 18, and there's our two numbers. We'll check, add them together, we get 34. Next up, the sum of 3 consecutive odd integers is 63. Find the three numbers. We've got 3 consecutive odd integers. So we'll just define the first one to be n. And then from this one, we have to add 2 to it to get the second number. Now from this one, we have to add 2 more to it to get to the third number. So if we add 2 more to this, we get n plus 4. And the second number should be 4 more than the original one. So there's our expressions for 3 numbers. The sum of these is 63. So we're going to add together all 3 of these expressions, n plus 2 plus n plus 4 equals 63. All right, let's combine like terms now. We have 3 n's here. 2 plus 4 is 6, so 3n plus 6 on the left-hand side equals 63. Subtract 6 from each side. 3n equals 57. Divide by 3. We get n equals 19. So the first number is 19. Add 2 to it to get the second number. Add 2 to get to 21, and 2 more to get to 23. So there's our 3 numbers, 19, 21, and 23. And if we add these together add to get 40, 50, 60, 63. So that checks. Now the next example is a little trickier because we don't define the second number in terms of the first number. Here we knew that if the first one was n, second one is just going to be 2 bigger, or n plus 2. And the third one is n plus 4. But we don't have such a relationship defined in this problem. Here it just says the sum of 2 numbers is 25. So we don't know what the relationship is between those 2 numbers. So we can't create an expression for one based on the other. So in this case, we have to define 2 different variables to start. Really no way around it. And then since we can only have one unknown in our final equation, we're going to have to eliminate one of those variables along the way. And we're going to eliminate it through substitution. So we'll see how that works out. So I'm going to call those 2 numbers x and y. And we know that the sum of these is 25. So x plus y equals 25. And now we're given the relationship between the two. The total of 4 times the smaller number and 2. So let's translate that. 4 times the smaller number, that's 4. And let's call x the smaller number. And y will be the larger number. So 4 times the smaller number. And it doesn't matter which one you pick. It's totally up to us. The total of 4 times the smaller number and 2. So 4x plus 2. So there's that phrase. Is, there's your equal sign. 6 less than twice the larger number. So let's start with twice the larger number. That would be 2 times y. Twice the larger. And then we want 6 less than that. So we're going to take away 6 from 2y. So 2y minus 6. So now I've got this equation we want to solve, but we have 2 variables. So let's get rid of one of them. And to get rid of one of them, we're going to go back to this equation and use this equation to eliminate one of these variables. And it doesn't matter which one we eliminate. So I'm going to solve this equation for one of the variables. So let's say I'm going to solve for y. I want to get y all by itself on one side of the equation. So I need to get rid of this x. So I'm going to subtract x from both sides. Let's do that over here. I subtract x here and subtract x here. All that remains on the left side is y. And on this side we get 25 minus x. So now we know that y is 25 minus x. So everywhere we see a y, we can replace y with 25 minus x because they're equal to each other. If things are equal to each other, we can substitute. Now when you substitute, put it in parentheses and keep the operations here. We're multiplying 2 times y, so that means we're going to be multiplying 2 times 25 minus x. So that has to go in parentheses. And now here's the equation we can solve, because now there's only one variable. All we see in this equation are x's. So that is solvable. Start by, we're going to get rid of these parentheses, so we're going to distribute in. 2 times 25 is 50. 2 times negative x is negative 2x. And minus 6 on the end. Now we can combine like terms. 50 minus 6, that's 44. So 44 minus 2x on the right. 4x plus 2 still on the left. And now let's get all the x's together. We'll have a big x party on the left. So add 2x to both sides. That's going to move all the x's over here. And since we have the x's on the left, we want to get the numbers to the right. So minus 2 here, minus 2 here. So we have 6 x's on the left, and we got 44 minus 2, which is 42 on the right. Now finally, we can divide by the coefficient on the x, and we get x equals 7. Now we define x to be the smaller number there, so x is 7. Now how do we find the other one? Well, we're going to plug it into this equation here. Plug it into the simplest equation you can. If we plug it into this one, then we got a whole bunch of stuff we have to do to find y. This one is much easier. So x plus y equals 25. I'll plug in 7 for x, so we get 7 plus y equals 25. Subtract 7 from each side, we get y equals 18. So there is our two numbers, 7 and 18. Your turn. 3 times the largest of 3 consecutive integers is 10 more than the sum of the other two. Find the three integers. So we're talking about consecutive integers here. So if we find x to be the first one, the next integer, we add 1 to get that one, and we add 1 to this one to get x plus 2 for the third one. So if we look at these, clearly, if we add 2 to it, this makes this the largest of the three. Here's your middle. And there's the smallest number. So now we can translate 3 times the largest. Well, here's the largest. So 3 times the largest is 3 times x plus 2. Is, there's the equal sign, is 10 more than the sum of the other two. All right, sum is addition, so we'll add the other two, the smallest and the middle one. X plus 1. Then we want 10 more than that. More than is addition, so we'll just add 10 on to the end here. So there's the equation we need to solve. So we'll start by distributing to get rid of the parentheses. 3 times x is 3x. 3 times 2 is 6, so we get 3x plus 6 on the left. And on the right, we can simplify by combining like terms. X plus x is 2x. 1 plus 10 is 11. So 2x plus 11 on the right. Now to combine like terms, I want to get rid of the 2x there. 3x minus 2x is x. And we got the x's on the left, so let's get rid of these numbers on the left, move them over to the right. So those go away. X equals 5. So that makes the first number 5. X plus 1 is the second number, so that's 6 and 7. So the numbers are 5, 6, and 7. Now we're going to learn how to apply these skills to application problems. The first one is about the fees charged by a ticketing website for concert tickets. So the fees charged is $350 plus $17.50 for each ticket purchased. If the total charge is $161, how many tickets were purchased? Now with application problems like this where we're going to set up an equation and solve it, whatever the question is asking for becomes our variable. The question is asking for how many tickets were purchased. So I'm going to find n to be the number of tickets purchased. Now we need to write an equation. The fee charge is $350. There's our set fee. So that'll just be 3.5. We don't multiply that by anything because that's only charged once. But we get $7.50 for each ticket. When you see that a certain dollar amount for each item, then we multiply the dollar amount by the number of items. We define the number of tickets to be n, so that's going to be 17.5 n. Number of tickets by the price per ticket is 161. So there's the equation we need to solve to find the number of tickets. We'll start by subtracting 3.5 from each side. we got 157.5 on the right. Now we'll divide by 17.5. And n equals 9. Nine tickets were purchased. Your turn. A homeowner would like all the outlets near water sources upgraded to GFCI. It's a safer outlet for using your water. An electrician charges $92 for a visit and $18 for each outlet upgraded. If the total bill is $308, how many outlets were upgraded? So $92 for the visit, that's charged once. So it's not multiplied by anything, just 92 plus. And it's $18 for each outlet. And I'm going to call those, I'm just going to define G, and G represents the number of outlets upgraded. All right, so there's our total cost, and the total cost is 308, so equals 308. So we'll start by subtracting the constant from each side. So 18G equals 216. Divided by 18. And G equals 12. So the electrician upgraded 12 outlets. Next example is about the length of some piano wire. A piano wire, 24 inches long, is cut into two pieces. The length of the longer piece is 4 inches more than 3 times the length of the shorter piece. Find the length of the two pieces. So I'm going to find two variables to start. So x will be the length of the shorter piece. And y will be the length of the longer piece. We know the piano wire is 24 inches long. So if we add these two together, x plus y equals 24. Now we can translate the next phrase. The length of the longer piece is 4 inches more than 3 times the length of the shorter piece. So let's directly translate that. The length of the longer piece, that's defined to be y, is the equal sign, 4 inches more than 3 times the length of the shorter piece. So we'll start with 3 times the length of the shorter piece. X is the shorter piece, 3 times the length is 3x. Then we want 4 inches more than that, so add 4. Y equals 3x plus 4. Now, just like the other example, we have two equations, or two unknowns in one equation, so this cannot be solved. But we've got this equation up here, x plus y equals 24. We can use that then to substitute for one of these variables. So I've got y over here by itself. It'll be easiest to substitute in for y, because then we don't have to distribute. So I'm going to solve this equation for y. X plus y equals 24. Subtract the x from both sides. We get y equals 24 minus x. So now we can take this 24 minus x and replace the y. Since these two are equal to each other, they are interchangeable. So 24 minus x equals 3x plus 4. Now I'll solve this. So I'm going to get the x's all to the right, so I'm going to add x to both sides there. Now I want to get the numbers all to the left, so subtract 4. And that gives us 20 equals 4x. Divide both sides by 4, we get x equals 5. That means the length of the shorter piece is 5. And if we want to find the length of the other piece, we can use this equation here. Actually, it's even easier to use this one. Just plug in 24 minus 5, and we get y equals 19. So the two lengths are 5 and 19. Your turn. A wire 24 inches long is cut into two pieces. The length of the longer piece is 6 inches more than twice the length of the shorter piece. Find the length of the two pieces. Now in this case, I'm going to use some more meaningful variables. So I'm going to use S and L for the length of the two pieces, shorter piece and longer piece. So S plus L equals 24. The length of the longer piece is, right, so there's our equal sign. The length of the longer piece is L equals 6 inches more than twice the length of the shorter piece. So we'll start with twice the length of the shorter piece. So that is 2s. And then we want 6 inches more than that, so plus 6. L equals 2s plus 6. So we want to substitute for L. So that means over here we should solve for L. Get L by itself. So subtract s from each side, and we get L equals 24 minus s. So replace L with 24 minus s. Now we can solve this. So plus s on both sides. It gets all the s's over here. So we'll subtract 6 over here and 6 over here. That gives 18 equals 3s. Divide by 3, and s equals 6. So the shorter piece is 6. I'm going to plug that in here. L equals 24 minus 6. L equals 18. So the lengths of the wires are 6 and 18. last example is about something we'll all need to deal with at some point, and that is an electric bill. An electric company charges 7 cents per kilowatt hour for the first 250 kilowatt hours. For each additional kilowatt hour, the company charges 12 cents. Find the number of kilowatt hours used by a family whose bill is 2434. So the bill is split up into two parts. One is for all kilowatt hours up to 250. And calculate the bill for that portion. And then calculate the other part by multiplying the kilowatt hours by 12 cents. So first of all, we need to determine the family used more than 250 kilowatt hours. So let's find the charge for using 250 kilowatt hours worth of electricity. If we multiply 7 cents by 250, we get 1750. So the bill is more than 1750, so clearly they went over 250 kilowatt hours. So let's define a variable. The question asks for the number of kilowatt hours used. So there's our variable. So K is the total number of kilowatt hours. And when we set up our equation, we're going to need to know how many kilowatt hours over 250 were used. So if this is the total number of kilowatt hours used, and that's K, that means we've got 250, then we've got some amount over 250. So we need an expression for this amount. So the total is K, and we want to remove this part to get just this part. So when we remove something in math, we subtract it. So up here we got K minus 250. And this represents how many kilowatt hours over 250 the family uses. Now we should be able to add these two things together and get K. K minus 250 plus 250 is K, so that works. Now the rate here is going to be 0.07 per kilowatt hour, and up here we're spending 0.12 per kilowatt hour. So there's the charges for the two different amounts of kilowatt hours. So we're going to need to add these two sections of the bill together to get the total bill. So the first part is 0.07 times 250. All right, there's the first portion of the bill. And the second part, for the kilowatt hours over 250, we're going to multiply these two together. So 0.12 times K minus 250. And when we add those two parts of the bill together, we get a total bill of 4234. And there's the equation we can solve it. So let's multiply these things out. Multiply these out to get 1750 plus, now we'll distribute into here. 0.12 times K is 0.12 K minus 0.12 times 250, that's 30. Now we'll combine like terms. Got a constant here and a constant here. We'll combine those two together. So 0.12K minus 1250 equals 4234. Adding 1250 to each side. You get 0.12K equals 5484. Now divide by 0.12. We get 457. So the family used 457 kilowatt hours. Your turn. A lumber company charges $4.50 for each 2x4. However, the company offers a discount for large orders. For every 2x4 after the first 20, the price is discounted at $3.25 each. If the total bill is $161.50, how many 2x4s were purchased? So there's all our information. $4.50 for the first 22x4s, $3.25 for each additional. The question asks for how many 2x4s were purchased. So there's our variable. We'll define n to be the number of 2x4s. So we need to figure out an expression for the number of additional 2x4s that were purchased. So we're going to exclude the first 20 because we're charging one rate for the first 20 and then another rate for all the additional 2x4s. So we need to take the total number of 2x4s and exclude or get rid of the first 20 because we don't want those in that part of the calculation. So n minus 20 is the number of additional 2x4s. So the first 20, we know exactly how much those are. It's 20 times 450. Now we also know this expression is the number of additional 2x4s. Oops. We got n minus 20 times their price, $3.25. So if we add together the price for the first 20 and then the price for the additional 2x4s, we get the total bill, which is $161.50. Now let's start simplifying. 20 times 450. That's $90. And now we can distribute 3.25 into this expression here. So we get 3.25n minus 20 times 325. That is 65. Which still equals 161.50 on the right. Now we can combine like terms. 90 minus 65 So that's 25, so we get 3.25n plus 25 equals 161.50. Subtract the constant from each side. So we get 3.25n equals 136.50. Divide by the coefficient, 3.25. And n equals 42. "42 2x4s were purchased." All right, this is a pretty tough section. Requires a lot of practice. If you're having trouble in the beginning, don't give up. Seek out help. And good luck, everyone.